Greetings, statisticians. It's me, Miss Wesley, and we are back at it today with measures of variation, specifically interpreting and finding standard deviation. Statistics packet, where we left off, top of page 12. We want to finish this situation about hurricane strikes per decade. While you're getting that ready and having your calculator handy, the joke is, what do sea monsters eat for dinner? Well, fish and chips. Okay. Next up, we had this data in our calculators from last time. So you put the number of hurricane strikes into L1. So I'll just go stat edit so I can see the numbers. And I want to do something to this list. Now, we went over last time how the calculator lets us find things like mean and standard deviation very easily. I guess I could go back to that too. So hopefully you were able to practice this and go to stat, calc, one variable statistics. Which standard deviation are you picking from this list? I hit enter. I see the mean, I see the sum squared. Which one of these do you pick? Unless otherwise stated that they want sample standard deviation, we're going to go for the population standard deviation, this little sigma that you see on your screen, the 3.51, which gives you your average variation. Now I want to keep the calculator close by while I answer question 2. What is the spread like of this data? Within how many standard deviations of the mean do all the datas fall? So what I want to try next is we're going to make a display called, usually call this a dot plot, but I might do it with X's. And I want to label this number line with values that will span the entire range of these hurricane strikes. So if I go back to my calculator and scroll down, it just gives me a quick, since the list isn't really in an order, it's in year or decade order, gives me a min to a max. We have to get from 12 up to 24. That's not too much to count, so I'm actually going to count by ones on this number line, and we'll start with 12. So we'll go 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 3, 24. And I'll label just the even. So 12, 14, 16, 18, 20, 22, 24. So just to be able to show you guys the spread of these values better, we could have made a box plot, but this is called a dot plot. You're going to put a dot, or in our case an X, floating above the number line at each of the values for the hurricane strikes. So the first one I see is a 19. And actually for the next step, I do want to see these data values in order, so I might as well practice with that now. Do you remember how to sort a list? I'm going to go to stat, and then see in this first menu, sort A for sort ascending versus descending if I want the numbers to go up. So then I can see sort ascending. It wants to know what list do you want to sort. I'll hit second and one for L1 and then enter. And now if I ever need it, when I go back into stat, calc, one variable statistics. Oh, actually, I don't need that yet. Sorry, stat and edit, how about? I'll see the list and I'll see that it's in numerical order from 12 up to 24. Now let's fill in the blanks. So I'll just go from, since it's hard to see everything on the screen at once, I'll go from my paper here. You're going to have a dot at 12, and I'll just put an X floating above the line. You're going to have a dot at 13. I think there were 2 decades of 14, so you're going to stack those one above the other. What it does, it's similar to a bar graph or a histogram where it stacks values so you can see these clusters of more popular data values. There's 2 years of 15s, so 15, 15. There's no 16s, but there was a decade of 17 hurricane strikes. 18, 2 19s, we'll stack those up. There was a 20, 2 21s, and then a little gap for 22, and no, there was a 22, sorry, and then a 24. How about that? So this is what it's looking like so far. I'll even give myself some room on either side. Now we see a little bit more of the spread of the data in these clusters that come up on this dot plot. We want to know within how many standard deviations of the mean do the data values fall. Can you use the space underneath of this and label the mean where it would go? It should be right in the center of the data. The mean we got was about 17.6. So I'm going to put that here with an arrow going down. The mean equals 17.6. And I want to visually make these barriers for cutoffs that are 1 standard deviation above the mean to 1 standard deviation below. Let's go above the mean first. So 1 standard deviation above the mean is going to be 17.6 plus 3.5. That puts me up at 21.1. So that's right above the 21s here. I'll put a line because they fall within. This is one mean plus a sigma, a standard deviation. 17.6 plus 3.5 gives me 21.1 for a high cutoff of 1 standard deviation above the mean. All of these meet the cutoff. How about below the mean? Let's try the same thing but to the left. I'm going to take 17.6 minus 3.5, and I get 14.1. A couple of those just don't make it. So the mean minus 1 standard deviation gives you 14.1. And we can tell all these 1, 2, 3, 4, 5, 6, 7, 8, 9 values fall within 1 standard deviation of the mean. Now that doesn't really answer the questions. They're saying within how many standard deviations do all the values fall? How far do we have to span out before we've captured every value? And I don't think we'll have to go much further. If we add 2 standard deviations to this mean, you're going to be 17.6 plus 7 plus 3.5 twice, and it puts you up at 24.6. That's way up here. So the mean, here I go in the way again, the mean plus 2 standard deviations gives you a high cutoff for 2 standard deviations above of 24.6. And the mean minus 2 standard deviations, I think, covers everything. It's down at 10.6. So it's down here. This is the mean to label it minus 2 sigma, 2 standard deviations, and we said it was 10.6, like that. We've covered it, all the data values. I actually want to write that here. Maybe I can, I'll see how this goes with me typing it. So we're going to say all values fall within 2 standard deviations of the mean. And that doesn't always happen. Sometimes if you have more spread out data, you'd have to go further. But later we'll be talking about normal, typical data. And for normal data, you can trust that generally you're not going to be too many standard deviations above or below the mean. Usual values fall within 2 standard deviations of the mean. So if you have hurricane trackers and they're trying to predict what's going to happen in the future, they shouldn't really expect values that are going to be outside of those 2 standard deviations. And that gives us a definition here. And this is a very informal definition, but it's worth mentioning. You can use standard deviation to find a usual range for a data set, and that is using the values we just found, the 2 standard deviations. So to find a usual value, the minimum usual value would be 2 standard deviations below the mean, or mean minus 2 sigma. That's your cutoff for a low usual value. The minimum and the maximum usual value is going to be about 2 standard deviations above the mean. So something to keep in the back of your mind, and this would be a plus here, 2 standard deviations, that you can have cutoffs or what you consider usual data values in this set. That's what you're going to see questions about moving forward. The rest of this is all about practice with these new statistics. Being able to know the idea of finding them by hand and then being able to use the calculator shortcuts to see if you can get them a bit quicker. I want to end with at least 2 of these. I think number 2 would be good to talk through together, and it'd be good to practice with me. You want to pause the video in a second and type in the values for number 2 into your L1, and then we can answer a very similar question to what we just tried. So I'm going to pause with you, so time out. Okay, time back in. And now what I've done in the meantime was enter carefully these values for number 2 into L1 on my calculator. No need to really put them in order this time. It's only 9 values, so it's not too much to deal with. Within how many standard deviations of the mean do all the data values fall? Can we do that now? Can we find the mean? So from the stat calc, try that. Stat calc, one variable statistics. Can you check me on this and see if you get exactly 13 as the average? And then for population standard deviation, sigma, see if you get 2 point, how about 2.91? So on average, you have these data values varying 2.91 from the mean. Now we can find our cutoffs. If you agree with that, let's get high and low cutoffs. 1 mean plus a standard deviation is going to give you a high cutoff for 1 standard deviation above and below, 15.91. So I already know we've kind of missed this first high cutoff because I see this high value a couple times of 17. Do we meet it in the low way? X minus sigma. So 13 minus 2.91 gives you 10.09. And actually, that's also not going to encompass all the values. 9 falls below that value. So let's go out one more. Let's try 2 above and below. So mean plus 2 standard deviations versus mean minus 2 standard deviations. I'll show the calculation. Mean is 13 plus 2 times 2.91 for your high cutoff, 2 above and below, 18.82. Did we meet it? Anything above 18.82? I don't see anything. That checks out. How about 13 minus 2 of those? Okay. We'll calculate it to be, 7.81. I think we've gotten it. I don't see any value in the list. The lowest one is 9, so nothing's below that. So we'll say within how many standard deviations do the data fall? They all fall within 2 standard deviations of the mean. Pretty cool. There's a couple good practice questions on this other side. A 4 I like a bit, so we could try that one. It says sometimes you don't know what the data is in the set, you just have some measures of center and spread. If I looked at 3 sets of grades, let's say in number 4, and all the classes got an average of 70, does that tell me the whole story? Do I know how everyone did if I just know the averages? Not really. If someone can tell me standard deviations are drastically different, like set A has a standard deviation of 10, set B only has a standard deviation of 5, and set C has a standard deviation of 20, we can talk more about comparing the spread of the data sets. So I'll just write a little comparison here. Which one was the most consistent? Which class was the most consistently around 70? Pick the one with the lowest standard deviation. We'll say set B is most consistently, let's say, close to the mean of 70. Okay, which is the furthest spread out. Well, set C has a huge standard deviation. On average, the people in that class, if this is grades, they're doing about 20 units above or below 70. They're getting 90s or 50s. Yikes. So we'll say set C is the most spread out. And A falls right in between the two. I think we can leave it at that for now. Another great thing to think about on your way out, number 5 says, what's the effect of an outlier, a far off value on the standard deviation? I know that outliers drastically affect what measure of center? It's the mean. The mean gets distorted, sometimes drastically, because of a far off value. And some people throw out outliers when they're talking about data sets for that reason. The median doesn't get too distorted because it still is the middle number, doesn't usually move that much. Standard deviation also does get affected. Think of what standard deviation tells you, how far your data values are away from the mean. An outlier is going to bring that standard deviation up, right? So I would say it increases always standard deviation. Doesn't matter if it's, when I should put that as a sigma, right? Population standard deviation. Sometimes you put an X subscript after it like your calculator would. So it doesn't matter if it's a high or a low outlier, right? It could be above the mean or below the mean. It is going to bring that spread up, okay? Enjoy practicing a little bit more, and let's see if we can analyze some more data together when I see you next time. Have a great day.